So in each of the following cases, we want to find the equation of the line that's being described. The line could be described in different ways. To begin with, the most simple way, they've already given us the gradient and the y-intercept. It's slightly disguised here, but that is the y-intercept. If it's 0 something, you're on the y-axis. We know that the equation of a straight line in general is y equals mx plus c, and you put the gradient there and the y-intercept there. So it's pretty straightforward. You just plug these numbers in the right place. It must be y equals gradient 4x, y-intercept 7 plus 7. And we're done. Y equals 4x plus 7 is the equation of this particular line that's described up here. In number 2, find an equation for the line with gradient 4 that passes through 519. Okay, starts in a similar way then, so surely this is y equals gradient 4 again for x. Common mistake now will be to write plus 19 to put this y coordinate, but clearly this is not where the graph crosses the y-axis. That would have to be 0 something. So instead, I need to work out the y-intercept. At this stage, it's probably a good idea just to say, I'm not sure what that is. So we know the gradient is 4, but we're not sure what the intercept is at this stage. Let's now substitute this point in to what I've got so far. We know that's the x-coordinate and that's the y-coordinate. Basically saying, if x is 5, then y would be 19. So let's substitute these in. We just said that y was 19, and that x is 5. Just putting these in the right places. 19 equals, or 4 times 5 is 20. Now I want to take 20 from both sides, so minus 1 equals c. If the c is minus 1, I can rewrite this properly now. It's y equals 4x minus 1. And indeed that does work, doesn't it? If you put 5 in there, 4 times 5 is 20, take away 1 is 19, as it should be. Okay, this time we're given 2 points. We know that the line goes through 3, 5 and 6 minus 1. There's only one line that can do that. If you force it to go through 2 points, it's one particular line. You can't have several lines that do that, it's just the one. The language of the question, just like the previous one, actually says find an equation, just because there's different ways of rearranging it. I think we ought to go for the y equals mx plus c form. It's the one we're most familiar with. But if you think about it, you can always rearrange an equation. So that's, if you're wondering why the language of the question says find an equation rather than find the equation, it's just because you can give your answer in different ways, but there is only one answer rather than several different answers. Okay, well, I'll show you 2 ways of doing this question. One way of doing it is to work out the gradient first. We can do that by way of a sketch. So this is roughly what the situation looks like. So 3, 5, I might say is the point here. 3, 5 is the point here. 6 minus 1, let's say, is here. This is 6 minus 1. To work out gradient, that's change in y over change in x. And in this case, I can see that, well, the change in y, it's gone from 5 down to minus 1, so it must have gone down 6. Change is definitely 6, and the change in x to get from 3 up to 6, that's gone along by 3. 6 divided by 3 is 2, but note that we've gone from here to here. That's definitely a negative gradient, so we'll say gradient is minus 2. In fact, you could have got that answer straight away if you said that the change in y was minus 6, went down 6, didn't it? Okay, so I now know the gradient. I can say then that y equals minus 2x. Not sure what the intercept is at the moment though, plus c. Just like before now, I can work it out by substituting one of these in. You can use either. You should get the same answer no matter which one you use. I'll probably take this one because all the numbers are positive, less chance of making a mistake. So that's my x, that's my y that I'll substitute into y equals mx plus c. So the y is 5 when x is 3. Minus 2 times 3 is minus 6. To get c on its own, I have to undo this, take away 6. Let's add 6 to both sides. C is 11, so I have my final answer, y equals minus 2x plus 11. You should get the same answer if you'd used the other point as well. Now, before I started doing this solution, I said there are 2 ways you could do this. It depends how much you like simultaneous equations. So rather than drawing the diagram here and working out the gradient first, you could have dived straight in with y, so option number 2, you could have dived straight in with y equals mx plus c and substituted both sets of coordinates in. So you saw that we could put 3 and 5 in there. So that's 5 equals, don't know what the m is at this stage. Well, we've worked out that it's -2, but if we didn't draw that, we wouldn't have known. So m times by the 3 plus c. So I've just substituted y as 5 and x is 3 using this coordinate here. That could be rewritten sort of more simply as 5 equals 3m plus c. Just put that in a box. It's not the answer to the question, but it's interesting for the moment. I could have said, using this one, that y is -1 when m is 6. Okay, that's better written as 6m. So -1 equals 6m plus c. And this is a pair of simultaneous equations. Okay, a pair of simultaneous equations. I might want to say double this one would give me 10 is 6m plus 2c. If I rewrite this one underneath, that's -1 equals 6m plus c. This would benefit from subtraction. Okay, 10 take -1 is, careful, 10 take away -1 is 11. 6m take 6m is nothing. 2c take c is 1c. So once again I get that c is 11. At this stage we don't know what m is, so you substitute it back in again. If c is 11, I can put it into either of these. Maybe I'll put it into this one. Oh, I've gone off the edge. My apologies. So I know that c is 11. Maybe I'll put it back into this one here. So that's 5 equals 3m plus 11. Take 11 from both sides. That's -6 equals 3m. Divide both sides by 3. -2 equals m. So now I know that m is -2 and c is 11. Putting it into y equals mx plus c, it must be y equals -2x plus 11, like we had before. So briefly then, when you're given 2 points, you've got a couple of options. You can either make it most like we were doing before, where you work out the gradient first by doing change in y over change in x, and then just substitute one of the coordinates in. But you could, if you wanted to, if you don't want to mess about with diagrams and you want to do it entirely algebraically, you can substitute both coordinates in. That doesn't give you the answer straight away, but instead it leads to a pair of simultaneous equations. Okay, this is quite a common example of question. This is using the phrase parallel this time. The whole thing is finding equations of described lines, and I've described them in different ways so far, but now the description involves a parallel line. What you have to be careful with here is only some of the information is important, and some of it you have to ignore. A common mistake here is to try using every single number you've got in the question, but that really would be a mistake. Okay, parallel lines have the same gradient. Okay, if I draw 50 parallel lines, if they're not going to touch each other, they must all have the same gradient. If you vary just one of those gradients, one will be steeper than another, they'll cross eventually. So parallel lines have the same gradient. This line in the question has a gradient of 6, so our line that goes through this point must also have a gradient of 6. So I can start off with y equals 6x. I'm just not sure what the y-intercept should be yet, so plus c. And you've seen this before now. I substitute these in. That's my x-coordinate, that's my y-coordinate. So sub these in to try and get the c. Y is 2 when x is -3. 6 lots of -3 is -18. To get c on its own, I'll have to add 18 to both sides. 2 plus 18 is 20. C is 20. So the equation of the line that's parallel to this but passes through -3, 2 must be y equals 6, x, same gradient, plus 20 is apparently the c that we need. Did you notice how we didn't use that at any stage? Okay, the y-intercept of the original line was not important. The critical thing about parallel lines is that the gradients are the same. They're going to have different y-intercepts, but the y-intercept doesn't control how steep the line is. And so parallel lines have the same gradient. That's the information we used. We didn't really use the -2 at any stage. Okay, so now coming to what most people consider the most complicated part in this topic is what happens when lines are perpendicular. You have seen this before, but I'll remind you. I've drawn 3 black lines and worked out their gradients. So this black line has gradient 2, this one gradient -3, this one gradient 4/3. Then got my protractor, measured 90 degrees, and I drew a red line which was perpendicular in each case, and then worked out the gradient of that line. So the red line, which is perpendicular to the thing with gradient 2, had gradient -0.5. The red line here, that's perpendicular to the line with gradient -3, has gradient +1/3. And over here in my final example, my red line, which has so my red line, which is perpendicular to the line with gradient 4/3, has gradient -3/4. Hopefully you notice the pattern here, that the connection between them is if you take this, you flip it over and change the sign, you get this. The posh word there is take the negative reciprocal. So if you flip over 4/3, you get 3/4, change the sign, positive becomes negative. Over here it's negative. Over here it was negative to begin with, and when you flipped it over, 3 became 1/3 because I suppose technically you started off with 3/1. You don't normally get write whole numbers as fractions, do you? But it was whole 3, so 3/1. Flip that over, becomes 1/3. It was negative to begin with, so the perpendicular gradient is positive. I claim that the rule makes sense because if your original line is steep and going that way, surely the one that's 90 degrees is shallow and goes the other way. Okay, so to get from steep to shallow, you flip it over, take the reciprocal, and to go from like a forward slash direction to a backslash direction, that's changing the sign. So flip it over and change the sign is what you do. So here are some more potential gradients. If you want the perpendicular version, suppose I've drawn this line with gradient 5 and I want to draw the perpendicular one, what would its gradient be? Well, if you flip 5 over, you get 1/5, and then change the sign. It was positive to begin with, so the perpendicular gradient must be negative. The original one over here is negative, so my new one will definitely be positive. I can't easily flip it over as it is, so I need to make it top heavy first. 1 times 8 is 8, 9, 10, 11 when you add the 3 on, so this is -11/8 to begin with. Therefore, when you flip it over, it's 8/11, and change the sign to positive. Okay, in the same way, it's quite difficult to flip over 0.8, but 0.8 is 4/5, isn't it? So the original gradient was 4/5. When you flip that over, that's 5/4, and change it to a positive here. If you flip 1 over, it's still 1, and positive becomes negative. If you flip m over, it's 1 over m. In the same sort of pattern up here, if it's just like a single number or an integer, then you get a 1 over and minus. Okay, so flip it over and change the sign. Let's apply that then to a question. So a bit like with the parallel lines, you have to be a little bit careful that not all of the information is useful, only some of it is. We've got this line that's talked about in the question. We're trying to find the equation of a different line. I want to be perpendicular to it, so I need to lift out the gradient. The gradient of the original line is important. The y-intercept of the original line is not important. It's red herring, not important information. So surely the line we want will have gradient 5/2. Or 2.5. Okay, not sure what the y-intercept is at this stage, but I can use this to help me work it out. You've seen this a few times now. Let's just substitute it in. Oh, my bad. It's going to be negative 5/2. Well spotted if you saw that. Okay, the original gradient was 2/5, so minus 5/2 is my perpendicular gradient. Let's then substitute these in then. The x is 6 when the y is 4, so if y is 4, let's stick that in, 5/2 times by 6. Well, half of 6 would be 3, so 5 halves would be 15. That's minus 15 there. Okay, to get C on its own, then I have to add 15 to both sides, so 19 is my C. So surely I've finished. That's y equals minus 5/2 x plus 19. Once again, notice how I didn't need to use the 5 here. That wasn't involved in the solution at all. If a question is asking you to work out the equation of a line, then it can be described in different ways. You've seen a few different options. It could just be that the gradient and the intercept is given. That's the easiest case. It could be that the gradient is given, but a point that's not the y-intercept is given, and then you have to play this kind of game where you substitute the numbers in. You've seen also that maybe you're given 2 points. If you're given 2 points, you could just work out the gradient and then do this kind of game, or you can do simultaneous equations. But the last 2 cases you've seen is if parallel or perpendicular is used, then we're not really interested in the y-intercept. We just lift out the gradient from the original line that's given. You might just use it if you're being parallel. You use the exact same gradient because parallel lines have the same gradient. Or you might need to flip it over and change the sign. Posh words, take the negative reciprocal, because that appears to be how perpendicular lines behave. If one line is steep, the other line is shallow, so it's necessary to flip it over. And if one's going in this direction, the other's going that direction, so it's necessary to change the sign. Okay, good luck with these.